So let's solve this diode network. So let's say this is R, this resistor is R, and we wanted to find the output voltage here, and that's the input voltage. Call this D1, call this D2, and the goal is to sketch the transfer characteristic. And find VA, which is the voltage at this point, VA. Okay, so let's assume that V in, the input voltage, is positive. Right before the network start, before everything start working together, we have VA, the open loop gain will be the open loop voltage, output voltage VA will be equal to the open loop gain V plus times V plus minus V minus. So when VI is positive, then VA will be negative, because VA will be positive also, right? Because so let's write it down. So we have VA, which is equal to A sum 0 minus V minus, which is VI. Okay, so this will be negative, right? Because VI is positive, and again the open loop gain is positive, so VI is negative. So VA is negative, so VA is less than 0. So when VA is less than 0, then D2 will be off and D1 will conduct. So when D2 is off, then we have this scenario. So let me sketch that. We have this, we have R, we have the op-amp minus plus, this is grounded, so we have R here, and D2 is open, but D1 is on, so I'll replace it by the voltage. This is point A. So because V plus is grounded, so VA in this case will be equal to minus VD on. Okay, the point A is still there, so it's from there to the virtual ground. So we have virtual ground here, virtual ground, because V plus equal to V minus when you have feedback. Okay, so that will be VA. So what is V out? V out will be equal to 0, because there's no current through the resistor, so V out will be equal to 0. Okay, so then let's recap. When VI is positive, V0 equal to 0, right? And VA equal to minus VD on. Now when VI is less than 0, VA, which is A times V plus minus V minus, so A times 0 minus VI So VI is negative, so this will be positive. So when VA is positive, so I turn D2 on. So D2 is on. And D1 will be off. Right, because A will have a positive voltage and the V minus is negative, so that the diode D1 will be off. So when the diode D1 is off, then what do we have? We will have this scenario. So let me redraw the network here. Have R, this is grounded, and we have the resistor R. That diode is open, D1 is open, so we have this point A, and we have this scenario, and this is V0. So for this case, VA will be equal to VD on plus V0. But we know the current in the network, so V0, so this is the current in the network, so I here, right? So if you agree with me, V0 is the voltage from here to here, right? Because this is still virtual ground. So V0 will be equal to negative Ri. So what is I? We know that Vi minus 0 over R equal to I. So then in this case, V0 equal to minus R times I, which is Vi over R. So it cancels out, the R simplified, so then we have V0 equal to negative Vi. Okay, so then when we recap, when Vi is positive, so D1 on, D2 off, VA equal to VD on, which is 0.7 plus no, what do we have? Equals minus VD on, so minus VD on, and V0 equal to 0. So when Vi is negative, D1 will be off and D2 will be on, and VA equal to VD on plus V0, which is minus Vi. That's VA, and V0 equal to minus Vi. So you can sketch the transfer characteristic. so we have V0 here, Vi here. So when V0 is positive, Vi is positive, V0 is 0. Okay, so V0 is 0. And then when it's negative, we have slope of -1. Okay, so V0 equal to negative Vi. This is V0 equal to 0. So Va equal to this, and V0 equal to negative Vi.